most people look at this video, they basically see an epic fail in the hurdle. And yes, it is an epic fail. Once we get past the humor embedded within the video, we can actually learn something. We can learn something about anthropometry and its applications in sport. Anthropometry is simply the measurement of the human body. Things like height and weight are anthropometric measures. But we also have wingspan, we have limb segmental lengths, we have body segmental lengths like trunk length, shoulder width, length of fingers, hands, toes, feet. Shoe size is an anthropometric measure. We also have body composition, percent body fat. We also have body mass index. We have any number of others, including circumference like waist girth, neck girth, your massive bicep girth. All those things are anthropometric measures. Virtually all sports use anthropometric measures either directly or indirectly to select for individuals that have a high degree of potential for success in their sports. The individual in the orange here, the red, is basically too short to be an effective high hurdler. The gentleman in the outer lane, in the blue, may have enough height, but he definitively does not have enough muscular mass, which we can measure that. That's an anthropometric measure, to get up and over the hurdles effectively. He can't generate enough height, even though his skeletal lengths are appropriate. But just because you don't meet the anthropometric measures that a sport may specifically select for or prefer, doesn't mean that you shouldn't participate. If these two guys really, really like the high hurdles, then that's what they should do. They should go out and run high hurdles. It just simply means that they're going to have to work really, really hard in order to succeed at the highest levels. Sport and exercise professionals or fitness professionals really need to have a firm grasp of what normal is. We need to be able to visualize in our mind what normal looks like. How do we do that? Well, there are charts and tables and numbers available for what normal is for any given population. U.S. male averages in height and weight is 5 feet 10, about 181, 182 pounds. For U.S. females, they're about 5'5" and about 154 pounds. While those are nice numbers and give us a crude idea of what things might look like, they're really sort of single-dimensional. Now, there are other norms that are out there as well. Body composition, percent body fat, we can find norms for that for any population and age. Circumferences, actually, U.S. military uses circumferences to determine whether a soldier is retainable within the military if he exceeds body weight standards. Shoe size, hat size, glove size, body mass, there are all kinds of other norms. But are they really useful? Height is useful because it's been used extensively in sports selection. One of the most evidence of those is the NBA. The 2008 averages, average height for NBA players was 6 feet 7 inches. There were only 7 players in the NBA that were under 6 feet tall, and almost all of those except for one were 5'11". The one outlier was 5'9". So height is clearly a selection. You must be taller than average to make it to the NBA, with very, very few exceptions. Football. In a 2009 study on high school football players in Texas, it was found that the top 100 college prospects on offensive line tip the scales at over 300 pounds. These are high school kids tipping the scales at over 300 pounds. And they were singled out because they were the best prospects for the next level of selection, collegiate football. So we can see that some of the simple anthropometrics are used in selection for sport. Others are as well. But most of us out here aren't really worried about selecting the best player for the best position on the best team. So we can win a world championship, we can win a World Cup, we can win an NCAA championship or even a state championship. What we need to know is how individual anthropometry, how our bodies put together dimensionally, affects how we exercise and how it looks when we exercise. Normal for one person, normal dimensions for one person, their individual dimensions, will make exercise look different from someone that has a different set of anthropometric measures. What we need to do as coaches, as trainers, is to be able to assess someone's individual segment lengths while they're exercise, and be able to create a geometric picture in our brain that enables us to put them in the correct position to generate the most effective exercise technique possible. Bones and muscles all interact together to form levers, basically physical machines. Because we are physical machines, we have to abide by physical law. That means that there are efficient and optimal exercise positions for every single exercise movement. The problem is that we've never really derived down to the basic nuts and bolts what these individual positions are and how they should look. The crux of the matter is that if I put someone in an inappropriate position, an incorrect position for their anthropometry, they are going to be inefficient, because I'm going to induce in place inefficient or extra levers and induce movement that's not either linear or curvilinear, and do not contribute directly to movement of the body or the implement or the other body that you're interacting with in as efficient a manner as possible. So we need to recognize individual anthropometry and how it, we need to look at individual anthropometry and be able to look at it and refer it back to normal and detect the differences between what we term normal and what we see in front of us, and sort of developing the coaching eye. A big question is, how do we actually recognize normal? How do we know that someone possesses long arms, long legs, long trunk, short trunk? How do we know this? Well, it's not really too terribly difficult. We just have to go back about 500 years to Leonardo da Vinci and his development of the Vitruvian Man. Everyone's seen the Vitruvian Man. Lots and lots and lots of professional professional organizations and businesses, sport teams, sports medicine, use this particular illustration by Da Vinci as part of their professional logos, mostly because it's copyright free and it's pretty cool, and it has direct application to our profession. Basically, the guy standing in a square is Da Vinci's attempt to represent the normal human that he saw. He based his work on Vitruvius, an engineer and builder that slightly preceded him, Also he was preceded and was contemporary, who wrote about average human dimensions in the form of a cubit. A cubit is basically the four widths of four fingers. 4 times 4, cube. So that's the derivation or inspiration of Da Vinci's original work. Da Vinci's model of the human body, of the average human body, basically broke it down into head lengths and some additional proportions or ratios. Now, while this may seem foreign to some people, this has been used in art schools and in illustration manuals by artists since the time of Da Vinci. Every time that you see some artist out there going, let me see, get this right, I'm doing this, looking at something, he's holding his thumb up, looking at something, or he's holding his paintbrush up, looking at something. What he's doing is doing something that Da Vinci taught us. We are measuring segments. They're doing a figure study. They're measuring segments of the human body based on head lengths or the length of their paintbrush stub or their thumb. It's to allow us to see scaling and relationships in dimensions. So what we need to do is we need to be able to look at the human body. We need to be able to look at the human body and divide it down into segments based on the human head. It makes it very simple for us to analyze normals if we can do something like